Hello, I'm Vanessa Palumbo and I'm a graduate research fellow at the Human Interfaces in Information Systems Laboratory at the Information Science and Technology Institute of the National Council of Research of Pisa in Italy. I'm one of the authors of this communication paper that I'm introducing to you, a paper that aims at providing criteria to analyze the transparency of automatic accessibility evaluation tools. This work starts from the consideration that with the increase in the number of directives and measures to make online contents accessible to all people, it becomes important to pay more attention to the web accessibility evaluation. However, web accessibility requires constant monitoring of many details across many pages in a given site. Thus, to simplify the monitoring, analysis, detection, and correction of website accessibility problems, several automatic and semi-automatic tools have been proposed. Although the accessibility evaluation can be fully automated, as specified in the relevant guidelines and documentation of these tools, they could offer useful support to stakeholders in making better decisions faster. There are in the literature a lot of works that conduce a comparison between these tools in terms of techniques coverage, completeness, or specificity of the evaluation. A matter of fact is that the results of the accessibility evaluations are different from tool to tool. This fact could suggest to the user a poor reliability of the instrument, and it could lead him to abandon the use of these automatic tools. For this reason, it becomes important for the user to understand as far as possible the functioning of these tools. In general, little attention has been paid to how the automatic accessibility evaluation tools should be designed to provide clear information about their coverage and working. The motivations generating these criteria are twofold. On the one hand, tools should provide transparent, detailed information on how they operate and with respect to what they are evaluating. On the other hand, the representation and visualization of the evaluation results should be clear enough to help users make decisions based on the accessibility assessment, also considering that often users of such tools have limited knowledge of accessibility principles and how to address them. In particular, to be transparent, an automated validation tool should make explicit the following four information on its operation. The first, what standards, success criteria, and techniques are considered. This would help the user to clarify the reasons for the different results in different tools. The second, how it categorizes accessibility issues. The more a tool utilizes the W3C standard classification for the accessibility issues, the more understandable its result will be for the user. The third, how the reported information is organized in terms of the capability of a tool in giving overall accessibility measures for entire web page or sites. In fact, the use of relevant metrics can help indicate the overall accessibility level of the considered websites. And the report formats depending on the target users. Different report formats can fulfill the needs of users with various expertise. For example, a code overview is more suitable for developers and a report with charts and statistics can be sufficient for non-technical users. The fourth, whether the tool can evaluate dynamic pages or not. Indicating whether a tool can evaluate dynamic pages is useful information that can help users interpret their results properly. Recently, websites have largely evolved into more dynamic applications. By evaluating the static HTML composing a modern web application, a tool may erroneously return no errors, sign that the tool is unable to assess the issue. We decided to explore the aforementioned criteria for each of four selected tools. In choosing the analyzed tools, first we considered their ability to test web pages against at least the WCAG 2.0 guidelines. Second, they had to be non-commercial and freely accessible on the web. In particular, we looked at HChecker, which is the longest-lived tool and one of the most used over the years, QualWeb, which is a recent tool and therefore representative of the most recent developments in this field. WAVE was chosen as representative of the tools that present the accessibility validation results directly in the user interface of the analyzed web page. MAUI++ was chosen because of its expandability due to the separation it effects between the guideline specification and the validation engine. The first criterion regards what standard success criteria and techniques are considered by such tools. In MAUI++ and Wave, this information is available in the help menu of the tool, where the user can find the full list of all techniques and criteria supported. In Wave, the help section provides also documentation for each icon and information boxes used to indicate the accessibility issue on the page during the evaluation process. In QualWeb, this information is available on the GitHub page, but they could be hardly reached by non-technical users. HAcker does not provide this information in detail. The second criterion regards how the tool categorizes accessibility issues. As we already mentioned, the classification of the accessibility validation results indicated by the W3C organization recommends using to indicate the test results passed, failed, cannot tell, inapplicable, and untested categories. HAcker identifies three types of issues: known problems that have been identified with certainty as accessibility barriers, likely problems that have been identified as probably barriers but require a human to make a decision, potential problems, which are problems that HAcker cannot identify and require a human decision. QualWeb provides the most complete report by categorizing the results as passed, failed, warning, and not applicable issues. A failure occurs when the tool can detect automatically if a given HTML element has an accessibility problem. A pass generates from elements that, unambiguously, are classified as having no accessibility problems. A warning occurs when the tool can partially detect accessibility problems which require an additional inspection. A not applicable issue occurs when there are not relevant elements on the web page to be tested. Wave contains the total number of issues for each of 6 categories called errors, alerts, features, structural elements, HTML5 and area, and contrast errors. MAUI++ categorizes issues in errors, warning, and successes. Errors are accessibility violations that can be detected automatically. Warnings represent a possible problem that cannot be verified automatically and needs a manual review. Successes are the elements that pass the test. The third criterion regards the information organization, considering 2 points. The first point regards the capability of the tool of giving overall accessibility measures. Among the 4 tools, only MAUI++ is able to provide metrics that can help the user understand the accessibility level of the evaluated web content. It provides 2 accessibility measures: the accessibility percentage, which shows the accessibility of the website in terms of the number of checkpoint types successfully evaluated, over the total number of evaluated checkpoint types for which the tool has been able to make the validation. The second measure is the evaluation completeness, which indicates the percentage of evaluated checkpoint types for which the tool has been able to make a validation out of the total number of checkpoint types analyzed. The second considered point of the information organization regards the use of different report formats depending on the target user. HAcker provides only a code-oriented report. QualWeb mixes the developer display and a preview of the user interface part that generate the accessibility issue through the visual representation button. Wave considers a double view of the accessibility results. The code-oriented one is available in the code panel at the end of the web page evaluated, and the graphical view for non-technical users is provided in its own structure. In fact, the evaluation is reported directly in the web page through icons that represent various issues. However, this is somewhat problematic if users have issues with the user interface parts that are not yet visible, such as, for example, hidden forms. MAUI++ provides a double view of the accessibility results. One is a code-oriented view, where errors and warnings are presented in the line number of the evaluated web page source code. The other is a graphical view for users without programming skills, which show errors and warnings through charts and tables. Regarding the 4 criterion, and so if the tool is able or not to evaluate dynamic pages, HAcker does not provide any support for evaluating dynamic web pages. QualWeb declares in the About section that a browser extension will be released soon, which means currently that we do not provide any support for dynamic pages evaluation. However, by analyzing the report provided for a single web page in QualWeb, it seems that the tool can evaluate it correctly to a server-side rendering capability. Mauvais++ and Wave provide a Chrome plugin to evaluate these dynamic pages. We have presented and discussed some design criteria for supporting transparency in 4 accessibility validation tools: HChecker, QualWeb, Wave, and Mauvais++. Developers of such accessibility tools should give a special attention to the amount of information presented by this tool to the users. In fact, if the presented information is enormous and very detailed, users could feel confused due to overload information. On the other hand, if the amount of reported information is not sufficient, the user could feel uncertain about the decision to make. In general, these tools tend to consider some relevant aspects, but there is still a need for substantial improvement to achieve full transparency. In future work, we plan to deepen and extend the analysis of automated evaluation tools in terms of transparency criteria in order to provide more detailed information for users, which can also be useful for choosing the most suitable tool for their purposes. By extending this study, we aim to develop guidance for stakeholders to provide meaningful and transparent information to the user. Besides, we plan to carry out usability studies to validate the criteria indicated for accessibility evaluation transparency. Thanks for your attention.